Hello everyone, I'm Miss Kana, one of your grade 11 maths teachers. In our previous lessons, we looked at logarithm, and it was really logarithm, natural logarithm, and common logarithm. We also looked at what's the difference between a natural logarithm and a common logarithm. We also used that to try to solve logarithm equations. But in today's lesson, we are looking at something very special, I think, and it is to do with logarithm table. Logarithm table. What is logarithm table? Looking back at mathematics, we have a lot of tables in mathematics that help us to solve mathematical problems like multiplication table, division table. We looked at a trigonometry table, and in today's lesson we would look at logarithm. But what is logarithm table? Well, logarithm table was created to try to help us solve big numbers look simpler. Now, let me just go on straight and look at an example. If I have log base 10, 1000, and log base 10, 1000 has a base of 10, we'd like to look at how many times with base 10 multiplied by itself to give us to 1000, and that is 3. If it had been expressed in index form, it would be 10 to the power of 3 is equal to 1000. Then 1000. Then let's look at another complex number, a bit bigger than 1000. So that would give me to log base 10, 1234. Looking at that, it looks scary. How am I going to calculate the power, which is easier on this side, but not that? So in that, I dropped my calculator yesterday, and I couldn't use my calculator to just enter log base 10, 1, 2, 3, 4, and obtain an answer. So that is when the logarithm table comes in. Logarithm tables were invented so that it can help us calculate complex numbers. And I will now look at my log table. So according to my log table, I have 1234. Now 1234 is a big number. So how am I going to calculate that in order to get me a power? Now, in logarithm, when we use the log table, we actually have two parts. And two parts, one is the characteristic, and the other part is the fantastic. Now, I would like to use that as whole numbers. And these, we call it decimal numbers. looking at the whole number and the decimal number, what will I do with the log table that I have in front of me? In the log table in front of me, I will need to simplify my 1,234. And I will first do step number 1, get the whole number value. And in order to get the whole number value, I will need this, 1,234, and write it in scientific notation form. And in order to write it into scientific notation form, it has to be multiplied by 10 raised to a power. So I go 1.234, and I multiply that by 10, 1, 2, 3 raised to the power of 3. Now, the whole number that I have to obtain would be 3. I'll nicely write it under there, right? And I could circle this as well. Now, that's not a problem with whole number. I have a problem now. How am I going to calculate the decimal numbers? So in order to calculate the decimal numbers, 1,234 has 4 digits. 1, 2, 3, and 4. I will look at the first 2 digits to my left, and the first 2 digits are 1 and 2. I will use 12, and on my table, I would go to row 12, and I will need to use 3, and 3 is the column. So I have row 12, column 3, where they meet. It gives me a value of 0.899. So I will write it over here. And I'd go row 12 and column 3. That would give me to a value of 0.899. You'll say, where did you get the 12 from? Where did you get the 3 from? I collected 12 from the first 2 digits of the number, 1, 2, 3, 4, and column 3, the 3 I obtained from the 3rd digit. That's still not enough. I need to look further. So that would give me to step number 3. And in step number 3, I would still use row 12. So on my table, I will have to go row 12, and I need the column. And the column will be the last digit, the 4th digit. So that would give me to row 12, column 4. Now, where will I find row 12, column 4? I'd go row 12, but I will have to miss the difference, and I go to the mean difference column. And in the mean difference column, I will look for 4. Where row 12 and 4 intersect, the value there is 14. And I will write my 14 over here. Step number 3, I will now get on to step number 4. No, step number 3. So in step number 3, I will have to add both the value of row 12 and column 3, which is 0.899, and I add it to the second, which is row 12, and column 4, which is 14. This I had not inserted any decimal numbers. So that would give me to 9 plus 4 gives me to 3. 1 plus 9 is 10, plus 1 is 11. 1 plus 8 would give me to 9. 0 plus 0 would give me 0. And I now have 0913. In the tables, if you look at the tables again, the table on the differences column, all of these, it represents the difference value. So it is all decimal except that the decimal number point had been omitted. So now I have 1, 2, 3, and 4, and I've got my decimal point, and I've got now a number to 0.0913. Now, that still doesn't give us the value that we would have to raise the log base 10, log base 10, 1, 2, 3, 4. Now, we said that if the whole number plus the decimal number, then it would give us to the result. So we've already calculated the whole number, and the whole number is 3. So we now have 3, adding that onto the sum of these, which is 0.0913, and it starts with 0.0913, and we have the sum of that then would give us to 3.0913. Therefore, we can now say that log base 10, the number 1234, would equal to 3.0913. This is our value. Looking at that, we can also now raise this into our original expression by writing 3.0913. How does it look if we were to express it in a form of indices, like what we did over here? I can relate to that, but at the moment I still cannot see it clearly, so let me write it in a form of indices. So the base is still 10. 10 is the base. The power is 3.0913, and that is equal to 1234. That completes what I need to put up there. Now, we have used the logarithm table to simplify the logarithm exercise or expression. Log base 10, 1 raised to the log base 10, 1, 2, 3, 4 is equal to 3.0913, where the base is 10, the power is 3.0913, and the result is 1234. That brings us to the end of the lesson of an example of how we could use the logarithm table to calculate the value of a logarithm expression. Now, we have covered numbers of lessons on logarithm, and that is, we covered logarithm properties, we looked at simplifying logarithm, we also looked at using logarithm to calculate equations, or we say logarithm equations. We have covered a couple of lessons on that, which brings us the logarithm table lesson to the end of our lessons on the topic on logarithm. With that, I hope you have learned something. I hope you have learned something in the teaching of logarithm. It looks confusing, but it isn't if we go through it step by step and simplify it. In our next lesson, we would be looking or recapping on the topics that we have learned in Term 1, and they're very important topics that we have learned, and we will look at that in our next lesson. Bye-bye.